will be Wi is equals to WCU. This is your condition for maximum efficiency. So Wi is nothing but your iron losses, and WCU is copper or variable losses. So whenever the both losses are equal to each other, then the transformer will be at maximum efficiency. Understood? So if anyone asking you at which condition transformer will get the maximum efficiency, it is whenever the iron losses gets equal to the copper losses. Right now, so try that derivation only in 2 to 3 steps, just to differentiation. If you are unable to get, then we will do it. I will share how to do that also. Try by yourself first. So till now, any doubts from complete unit of transformers? I think maximum topics we covered. Check once the syllabus. But I shared the syllabus to all of you. Check the syllabus copy. Done. Transformers. No payments. Efficiency is the last topic. And there is a three-phase transformer concept is there that I will explain on board. Okay. Meanwhile, I will share the video related to that three-phase transformer, so you can go through that. Anyhow, tomorrow on board I will explain. It is a very, very important topic where you have to do the experiment also on that particular topic, so that you will get better understanding once you did the experiment. Can anyone tell me what are the units or rating of transformer?
What?
No. Rating of transformer should always what? What are the rating of transformer? It's not watts or kilowatts. I clearly explained why it is not watts and what is the answer.
VA, sir.
VA, very good. Volt amperes. Why? Because it depends on losses. Iron losses are depends on voltage parameter, and the losses are depends on current parameter. So the units for voltage is volts and the units for current is amperes. So that the rating of transformer is an volt amperes farad, kilovolt amperes farad, megavolt amperes. So what does it mean by K? 1K in the sense 1 into n cube. 1 mega is equals to 1 into 10 power 6. 1 milli. Identify the difference. Mega is represented by capital M. Milli is represented by small m. Milli in the sense 1 into 10 power minus 3. Micro. Observe the symbol. Micro in the sense it should be 1 into 10 power minus 6. And the nano in the sense it should be 1 into 10 power minus 9. Similarly, pico represented by P. 1 into 10 power minus 12. Okay. Right, understood? The representations of powers. Still we are having time, so that I will complete the derivation part. So you people have to tell me how to solve that differentiation. Where we stopped in last session, that differentiation d eta by what is the parameter we taken from input side or output side? That efficiency equation. Some efficiency equal to we return in terms of losses. Output power by output power, that is V2 to transfer by output plus losses, right? The same we return.
Yes, sir.
Right. Wi plus
Wi by
I2 square.
I2 square V.
Correct. So then we
Yes.
need to differentiate the equation with respect to the variable quantity, that is a secondary current I2, and making equal to 0 in order to get the maximum efficiency. So therefore d eta by di2. So differentiating equation 1 with respect to I2. So U by V formula, what I mentioned last class, V2 I2 cos phi plus Wi plus I2 square R2 whole square. This is your V. Now V into du. So V should be remains the same. Once again I need to write Wi plus I2 square R2 and V into U. What is the formula? V square U du minus U du, right? U by V formula. Now V I return in the numerator du. U is V2 I2 cos phi. Now differentiation of this one. Differentiating with respect to I2. So remaining is constant. V2 cos phi minus this factor U dv. U is V2 I2 cos phi. Next dv. dv in the sense we need to differentiate the denominator of efficiency, that is I2 with respect to I2. Therefore V2 cos phi plus Wi is 0 since it is a constant loss, and I2 square R2. I2 square R2 in the sense 2x square. Simply I2 square in the sense x square. Differentiating with respect to x, then it should be 2x, right? So 2 I2 R2. Correct? Understood now, all of you till now? U by V formula, that is equal to 0. Now clear up to this step, all of you?
Yes, sir.
Now just to do the simplification, cross multiplication, it will be 0 denominator, and a numerator you can simplify. Multiply these two words. So V2 square I2 cos phi plus V2 cos phi Wi plus V2 I2 square R2 cos phi minus, multiply the second components. V2 square I2 cos square phi. Here also cos square phi, first one. Next minus into plus minus V2 I2 into I2 square 2 and R2 cos phi equal to 0. The denominator cross multiplying to RHS side will be 0. Now see this component plus minus will be getting cancelled, and Wi V2 cos phi. See, this is and this one both are same, but this is double 2 times. So if we are getting common, minus V2 square cos phi R2, then it should be 1 minus 2. So 1 minus 2 in the sense minus 1, right? Equal to 0. Now again, from these two expressions, we can take common factor of V2 cos phi, V2 cos phi, V2 cos phi. Then it will be Wi minus I2 square R2 equal to 0. Wi is equals to I2 square R2. What is I2 square R2? Copper loss. So Wi equal to WC. Understood now? The final conclusion, what I mentioned here. Here it is. Here. Obtain the condition for maximum efficiency, that is Wi is equals to WCU. Iron loss is equal to copper loss. How we obtain from the simple differentiation of either the formula by taking the efficiency. Clear all of you?
Yes, sir.
Right. Note it down. All of you note down. No? Right, completed.
Yes, sir.
Right. So I shared one video on three-phase transformer connections. So I'll have to go through that and noted down all the four configurations as much as you can understood. If anyone unable to follow that, tomorrow I will explain in the classroom, right? And Vedant, take the screenshot of participants list so that I will update the attendance in ERP. Post in our group.
Sir, posted, sir.
Okay. And one more announcement to all of you. So tomorrow you are having the BEE lab, right? Afternoon session. So in that session,
Yes, sir.
the corrections will be done for the experiments of what you did in online mode. That is two experiments. One is a brake test on DC shunt motor, that is performance characteristics of DC shunt motor. And second one is verification of impedance and current, right? For RL, RC and RLC series circuits. So make ready with your observation and a record of these two experiments, right? Tomorrow you have to once done in the lab itself with your hands on, and then the corrections will be going to complete by tomorrow for these two experiments. Clear all of you?
Yes, sir.
All right. Record also you need to complete and come with all the data of your observation and record for those two experiments. And for the remaining
Sir.
students, yes, ma'am.
No, sir. They are same.
Anything you want to convey?
No, sir.
Right. So for the remaining batch of students, that is other than tomorrow's BEE lab, who are going for AP lab. So for those students, you have to come up with your observations only, not with the records. Come up with observations and complete your corrections first. That is this third experiment and fourth experiment. And in your next lab, you have to complete your record corrections and the hands-on demonstration of the experiment. Right, ma'am?
Yes, sir.
Any queries on tomorrow's lab? And tomorrow's class will be topic three-phase transformers. So prior to that class, go through that video lecture. Having any doubts, note it down. So tomorrow morning we will try to complete it as early as
Sir,
possible.
one thing, sir.
Yes.
Sir, the second batch have missed the last class of B3 and today it was for us. Means the second batch was there.
Whoever the batch, no issue. Corrections are not done, right?
Yes, sir.
And hands-on experiment not done, right?
Yes, sir.
So both batches are on same platform, no issue, right?
Okay.
Right, right. Thank you, ma. Thank you all.